like the scientific method and how we're going to try to build our process today. But first, let's talk about what is happening here with this fetch. You had a little discussion question this morning, and you're kind of like, oh my God, it's so weird. But before we even dive into it, we need to understand why we want to use something like fetch and why we want to use these like network requests that don't exactly work line for line in the way that we think. So let's do this. Boop, boop, boop. Here we just have some regular Ruby code, good old predictable Ruby. And all I'm going to do is I'm going to pull in these three things, right? I'm going to pull in something called REST client. I'm going to pull in something called JSON, which I'm going to explain in a second. And I'm going to pull in my good friend Pry because I'm a terrible developer and I need to debug. So what is JSON? I call it JSON. So if you hear me say that, just that's what it is. Very good. JavaScript object notation. God, I missed that. God, I missed that zoom. Oh, you didn't? Powerful. So what is JavaScript object notation?
It is a language agnostic, so it works in multiple languages.
Yes.
A way of representing hashes and arrays in a nested structure.
Correct. It is a language agnostic data structure. So the idea is that if I'm using Ruby and I'm getting data from the internet, I should be able to turn that data into a Ruby hash. If I'm working the exact same code in JavaScript, I want to be able to take that internet data and make it a JavaScript object. If I'm writing Python, I want to take that data and turn it into a Python dictionary, like a key value pair so that it's language agnostic, but everyone sort of understands what it is, right? So this will make more sense here in a second. But right now, this app, all it does is it says, yo, I'm going to take this quick nap, BRB. When's the last time you said BRB? Never, right? Oh, you did, you're right. It's hard to say BRB because we're so connected in today's world. So back when I was growing up, back in ye olden days, we did something like this. Do you know what this is?
Away from keyboard.
Away from keyboard? But are you ever away from keyboard? Like you're on your phone all the time. This doesn't exist. This is legacy. It's deprecated. Oh, wow. Oh, coding jokes. Got it. Okay, very good. So the idea is that there's a built-in sleep function inside Ruby. And all it does is it waits the amount of time that you put in as argument. So sleep 5 is just going to wait 5 seconds. And then it's going to say, okay, I'm waking up now. And then it's going to go, I'm going to make this HTTP request. Do you guys remember REST client for Mod 1? It's essentially a gem for Ruby that allows you to make network requests. But what type of request am I about to make?
Yeah.
Very good. Did you also not see that?
No, I didn't.
Wow. Plus. So you're making a GET request, right, to this particular route, this URL. And all I'm going to do is I'm going to store it into a variable called Ron Swanson quote response. So there's no like var letter const because Ruby is very nice to us. And then all I'm going to do is I'm actually going to pause it right here because I want to see what comes back. I want to test that response, right? So again, that scientific method. I'm actually going to attempt something. I need to make a guess as to what it is. And then I'm actually going to set the controls by basically putting the binding pry or the debugger, the bybug, wherever, where it makes the most sense. Either immediately before or immediately after the code line that's in question. And so that's kind of the idea. And then we're going to test it. So I'm going to run it and then literally look at it to see if it matches my hypothesis. If it does, odds are I genuinely understand it. Otherwise, I need to reevaluate my understanding. So let's actually take a look. How can I run this file, this sync.rb file? That's right. I just drop a little Ruby, and then I type in sync.rb. So what can we expect to see happen side by side? It's going to print something. It's going to stop for 5 seconds, and then it's going to print something else, make a request, and then hit the binding. So, all right, it's going to take that quick nap, right? And it's going to wait the 5 seconds. And then it's going to wake up and make the request. And it's going to hit the binding. Chet, you mind hitting that light for me real quick? I think my code editor is not perfect. Is that more better?
Yeah.
All right, cool, sorry. Whoa! Okay, cool. So the idea here is, what do I want to actually test? What information right now am I not sure of? Like, am I not sure about this puts? No, I definitely saw that push. That came out. So really what I'm testing is this REST client response. Like what actually happened here. And so again, that scientific method, like procedurally, systematically figuring out what the line in question is, what I'm unsure of, and figuring it out. So what can I assume? What is a hypothesis for this Ron Swanson quote response? What do we think it is?
Whatever functionality we're trying to achieve with that is working because it didn't break on that.
Okay. Right, whatever the functionality is. The idea is this. Do you remember back in Mod 2 when you had that bcrypt lecture? Great, and you did bcrypt.create or bcrypt namespace password.create. What type of object came back? What was that class object for the bcrypt.create? It looked like a string, but what was it? It was, no, that password digest is the column in your schema. If I did bcrypt password.create, it looks like a string, but if I check the class, it's in fact a bcrypt object. If I do animal.create, what type of object is that? Is that a string? Right, it's an animal object, right? So if I'm doing REST client.get, what type of object do you think I should get? A string? I should be getting a REST client object. So that's our hypothesis based on our understanding of sort of Ruby. So let's paste this and see what the return value is. It looks like some sort of REST client response, which kind of makes sense, right? I do a REST client.get, it goes and gets information from the network, and then it comes back with a response. So Mod 2 is all about that request response cycle. So if I make a request, I get back a response, everything seems to check out. If I take this response and I check the class, the hypothesis is that it's a REST client object. And there it is. It's a REST client's response object. So right now you can kind of see in like this array that there's something in there, but I don't really have access to it. So as we talked about in the internet, the idea is that the internet typically holds a lot of data, right? But for developers, one of the most common forms of data is if I can store everything in JSON, right, this JavaScript object notation, it doesn't matter who's pulling it, as long as they transform the JSON into their language, they can do something with it. So right now, this data came from the internet. I'm just going to assume at this point it's probably some sort of JSON-like object. But I need to change it into Ruby. So what I'm going to do is I'm going to take this JSON and I'm going to parse the Ron Swanson quote response. I have access to JSON because if you remember, I required it in my Ruby file so that this JSON exists. So I'm going to parse this JSON and I'm going to turn it into a Ruby object. And look, I get an array back. But I'm not sure if it's really an array or if it's like, I don't know what this could possibly be. It looks like an array. So how can I verify? Well, I want to check the class, right? So I'm just going to do .class. And I see that it comes back as actually an array. So now I know for sure that this is a Ruby array that I can sort of manipulate. So let's actually store that into something. So I can store this into like cool quote. I'm sorry, that's not right. Cool quote, right? Little JavaScript mistake there, little boo-boo. So now if I look at cool quote, I see that it's this array. And now I can kind of do things to it, right? If I actually wanted the string, I can go into it and just get that first object, just get that first item in the array, which is the actual string. So far, so good? Any questions on like that whole like thought process behind like testing what it is, making sure the object type makes sense, and then being able to manipulate it accordingly? Question or stretching?
No.
Okay.
So if you're just getting a response back, what exactly is JSON parse doing with that response?
Correct.
The response is a JSON, or?
Well, let's do this. If I were to go to a website like Reddit, oh no. There, that's what I was looking for, this one. The idea is that the internet can respond with a couple things. They can respond with HTML, which I'm used to, or it can respond with something called .json. So if I go here This right here is just a large blob of data,
Yeah.
right? What does this look like, though, with the curly boys? What kind of data would this be in JavaScript? Try again. An object, right? Hash would have been correct if I said Ruby, so you're basically right. Basically right. You're right. So, okay, inside data, what kind of data is this? Inside data. Another hash. Inside children, though, what am I looking at? An array. So this right here is just one large object, right? If you are not seeing this, right, if you happen to be coding along, the idea is that if I click raw, this is what it actually looks like. Clear as mud, right? If you're trying to get data out of this, good luck. So there are Chrome extensions that allow you to actually what is known as pretty print, and that is it puts in these spaces, it puts in the tabs, it does new return lines, and it will color code them. So the one that I'm using is actually called JSON Formatter. There's JSON Viewer or whatever, it's a Chrome extension, and it allows me to do this. Oof, wow, look at that. I could see green are strings, blue are numbers, and then all the keys, this is readable data. If I make a GET request to this, right, reddit.com/usersjson, what I can really do is replace this here, and I will get back that large data there. But that large data is in this JSON format because, as you could tell, the network responded with a JSON object. I need to take that JSON object and turn it into a Ruby hash. And that's basically what's happening. So JSON is basically, JSON.parse is a gem, and it will convert JSON into the appropriate language-specific data structure. Cool? Does that answer your question?
Yeah.
All right.
And do you need to turn it into Ruby hash?
Right now, with Ruby code, I need to turn it to a Ruby hash. But if I'm working with JavaScript, I need to turn it into a... That's right. Ooh, thank you for not saying that disgusting P-O-J-O word. Ooh. I don't like it. I don't know. That's just a personal opinion. I'm sorry, I thought you had a question. All right, so, no, you did this. And I was like, ooh. All right, great. I love the questions. Again, I just want to give you fair warning. This is the hardest part. So the second I start to say something, I think I'm explaining it gloriously, but the second I say something that you're like, ooh, Evans, that made no sense to me, even if you don't have a question formulated, if what I say doesn't make sense, I really need you to raise your hand. This is probably the one that you want to really jump in on, all right? So let's take all of this and take it into JavaScript land. So far so good on Ruby, right? Okay. Now let's do index.js. And what I'm going to do essentially is exactly the same thing and show you what kind of user experience that creates. There's no such thing as sleep organically in the JavaScript language, so I had to make one up, right? Basically what it does is it sets a number to 0. I use let, right? And the idea is that I'm gonna run this while loop. JavaScript, as it's defined, is a single-threaded, non-blocking, synchronous programming language. I'm gonna break that down for you. All right? It's single-threaded, meaning it can only run one thing at a time. All right? So if I'm running this sleep function, nothing else can really run while this sleep function is running, so to speak. All right? It's non-blocking. That is just to say that the code should not block what is known as the thread or the call stack. Who watched that 3.5-hour video about the call stack? Okay. The idea is that JavaScript will basically run a certain way, and I'm going to break that down. And then it's single-threaded, non-blocking, synchronous. That means it does one thing at a time, top to bottom, left to right. But now we're going to talk about something called asynchronous and why that's kind of really throwing some folks off. All right, so async meaning it's happening sort of at the same time somewhere else, right? Versus synchronous, it's all happening at once in front of you. So again, this sleep function is sort of nebulous. The idea is that I'm going to count 12 to the power of 8 because my computer is so fast that I'm going to multiply it by n. This kind of winds up being close to a second. And then it's just going to I++. So here's what's going to happen, right? I define this sleep function. I'm going to console log, I'm going to start the sleep function. I'm actually going to invoke the sleep with a number, like, let's use 7 instead. 10 might be a little long. And then it's going to console log, wow, that sleep function took forever, 1 star. Cool? If you remember anything from Andrew's Chrome Boy powerful lecturing, does he remind you guys of me a little bit? How dare you? No, I hope you liked him. He's a very good friend of mine. But anyway, so the idea is that you're familiar with event listeners, yes? Eat. So what I'm going to do is I'm going to grab something on my page, right? This element by ID called click button, and then all I'm going to do is add a click event, and all I'm going to do is it's going to fire this callback function, console log, and all I'm going to log is you done clicked me. Eat beef powerful. All right, sorry, that was stupid. So if I go to the page itself, I have this. There's like this ajax, right? If we look at the HTML of this page, I see ajax and fetch. I see this click, right? The button ID is click button right here. So I'm grabbing the click button. That's what I'm doing right here with, oh man, let me do this, sorry. Get element by ID click button. So I'm going to grab this particular click button with the name of click, which is right here. And then what I'm really doing is I'm just going to console log once that button is clicked. So far, so good? So let's actually see what happens. On refresh, the idea is I should see, this is the scientific method, right? This is my hypothesis. I should see this console log. The sleep function is going to run, and then this console log will fire. Will this fire while this sleep function is running? No, that's the hypothesis, right? Because we talked about it being a synchronous, single-threaded programming language. And then I have this event listener with click. So the idea is that while sleep is running, are these clicks and this callback going to fire while that sleep is running? No. So let's test. I'm going to hit refresh, and then I'm going to sleep it, and I'm going to jam this click button a million times. So if you took a look at what actually happened, it started the sleep, it waited for a little bit, and then it console logged, and then it fired the event. Let's raise that sleep a little bit to 11. Let's crank it up to 11. I'm going to clear the logs. Then I'm going to refresh one more time. Remember, it's going to sleep for like 11, not really seconds. My computer's too fast. But I'm going to click like crazy. So click, 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 click. So it's still loading, but notice how those events didn't fire until the sleep was done. So was our hypothesis correct? Yeah, it was. So the idea is that the sleep function is known as blocking. All right? Blocking just means, kind of like how you heard in the event loop video, it just means slow code. That sleep function takes so long to run that nothing else can really run until it's done. And so, is this a good user experience? No, 1 star. The idea is that back in the day, I know this class is a lot young, but back in the day we had things like this, where you would go to a website and until the whole website loaded, you couldn't scroll. You would click something and you're like, it's not working. You'd click it a bunch of times, and then finally the page would load and everything would happen. Like 4 pop-ups would happen, you'd be like, this is not what I wanted. You'd get frustrated. It's a bad user experience. So the idea, and I see your question, the idea is that what I want to do is not have this blocking code. And right now, making a network request, how long does a network request take? When you're on Rails, right, and you did like animal/1, how fast did that come back? Instantly. But did it come back instantly every time? Yes. Well, lucky you. The idea is that, how many of you have done this? You did Rails S and then immediately try to hit one of your routes. Did that happen instantly? No, right? Sometimes network requests, for whatever reason, can take X amount of time. We don't really know. So if you could think of the sleep function as how long the network request will take, The idea is that sometimes network requests will take 4 seconds. Do you want everything else on your page to not run while this network request is happening? No. So the idea is that we need to make these network requests asynchronous. They need to happen and should happen sort of in the background so that the user can still play with the page and it's not blocking. That's why we're using an asynchronous request. Cool? Your question?
So you said that JavaScript is non-blocking?
Yes.
You can write it to debug?
Correct. The idea is that the code can be blocking, but you want to write it so that it doesn't block. Okay? All right, so who feels comfortable about what blocking is? Like I understand blocking code. You don't have to necessarily be able to write it, but you can visualize it, right? So let's do this. Let's get rid of this blocking. Embarrassing. And let's actually do this. How do we make network requests in JavaScript? Well, we had a little discussion question about it today. So instead of REST client.get, which is the Ruby way, right, the browser gives you something called fetch. So fetch is how we essentially make these network requests. So what I want to do is I want to do fetch, right? And fetch takes in an argument. What argument do you think fetch would need? Right, the URI. Like, where am I actually going to make this network request? So let's do this. Let's actually comment all. Whoop. I was going to comment it. That was a dirtbag move. And let's actually just pull the Ron Swanson quote, right? Just so we're sort of on the exact same page. So if I do the fetch, I'm just going to get this Ron Swanson quote. Now, who feels like they really understand what is happening and what's going on? Or is this a good time to test our hypothesis and go step by step and run that scientific method? We should test, right? And so the idea is that, like, okay, do I have access to what this fetch is, or should I store it in some sort of variable? Right. So unfortunately, like Ruby, I have to make a declaration. So var let or const, which one are you going to choose and why?
If this is a source of information, then you don't want that to change.
Yes, this is a source of information. I'm not necessarily going to change or reassign it. So I'm going to put const, and I'm going to put the data. The data, right? Whatever that means. I don't really know what this is yet. So now I actually have to test this. So how do I test it? I could console log, right? But now I want to introduce you to something that we use in JavaScript, and that is known as the debugger, which is really cool because the way to use it is you just go bloop. You just put debugger. I'm used to putting semicolons, so that's just a habit. But you just write debugger here. The debugger will only fire. It's like binding pry. It's like bybug. Will only fire if the dev tools are open. All right, so you can refresh your page all you want, but if the dev tools aren't open, it actually won't pause your code. So what it will do is it will just pause your code. It'll just read through this and then pause it right here on line 25. Cool. So if I refresh with the dev tools open, the idea is that you will start to see it hit the debugger. The dev tools will hit. So there's a couple things I could do. I can go right into my console, and I could see, I've defined the sleep function, but I've never actually invoked it. If what I'm saying is true about the debugger, do I have access to the sleep function here? Yes, so let's check. Oh, look, there it is. The sleep function exists. And it's the one that I wrote, right? So far, so good. So what do we want to test here? We want to see, like, hey, what is the data? So let's actually see, like, what is the data? It looks like it's this promise. So what have you gleaned from sort of the discussion question?
Okay, so I don't fully understand it, but from what I understand so far, it seems like there are kind of like, so the computer will run into something. It's like, okay, we want to run this, but we need to do one thing before we do another, so we're just going to sidebar this thing, then proceed with the code, and then when the code is done running, then we'll execute this other thing.
Right. So it basically, right, to sum up what you're saying, is it tells you, hey, this fetch is going to go grab some data. Where? Well, it's the string that I told to go get, right? The idea is that it will now come back with something called a promise. Look at this fetch right here. Let's take a look and a little bit closer peek. Is this a function that's being invoked? Yes. That must mean that whatever this data is has to be the return value of the fetch. If fetch is being invoked and I store it into a variable, this is the return value. We hammered this on day one, right? If I had a function here, right, that was called Vera, boop, 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 and it returned, right, blogs are for chumps, right? And I simply did a const, right, B is for blogs or vlogs, whatever, and I did Vera, and I invoked, I'm executing the code Vera. Nobody caught that very good. What would the const be? Right, it's blogs for chumps, the string. Whatever I invoke is the return value that's being stored in here. If that's the case, then that must mean the data here is the return value of the fetch being invoked. So what does fetch return? A fetch returns a promise. So far, so good, right? Sorry if this is slow, but this is, like, again, super complicated, so I want to go very, very slow. So fetch returns a promise. Interesting. Now let's talk a little bit more about what's going on. The idea is that fetch returns a promise, and we have a promise object. If I open the promise object, I see a couple things, and that is it's pending. Why would this be pending right now, and why is this still spinning its wheels?
So the debugger paused all code.
Correct. The debugger paused the code. It went to go grab this data, this fetch, and then I paused it. It never actually had opportunity to come back. And you could think of a promise as exactly what it sounds like in English, right? The thing that we like to do as developers is we like to name things that make sense, hopefully. So promise is what in your own personal definition?
A statement about the future that something is going to happen.
Correct. It is a statement about the future. Did you just talk to my friend Miriam in Webster? Okay. It's a little dictionary joke for you English folks out there. Okay, you didn't like it. Very good. The idea is that it's something that, hey, this is going to happen, but later, right? So this example I like to use is like, let's just say I'm like horribly hurting for money, and I'm like, yo, Chet, let me borrow that $50 real quick. I promise I'm going to pay you back. So there's some sort of IOU, right, happening. So let's think. This promise, we can always look up on the MDN, which is our favorite website for JavaScript. We'll tell you there's a couple of methods that you can run on them. One of the methods I'm just going to tell you about is known as the .then method, which makes the most sense because if I promise you something, right, I promise I'm going to go to this website, Ron Swanson quotes, Heroku app version 2, and I'm going to grab this data. Well, what do you want me to do when I come back? You want me to just like hang out, or just what exactly are you looking for? In the same way that if I asked you, hey, can you please go get me some, like a marker? And then you give me the marker and I just stand there holding it. You're like, okay, what's going to happen here? So the idea is that if I tell you to go do something, I need to tell you what to do when it's done, when you come back, right? Give me the marker and then take a seat and we're going to continue the lecture, right? Just the English on it sounds really good. So if I have a promise, I can always do on the promise .then. I'm literally chaining a method here. I'm invoking a .then on the promise because fetch returns a promise, right? So if fetch is being invoked, it returns a promise object. I'm doing .then on a promise. So if I'm doing .then, the weird thing is, like, how do you tell code what to do? You have to write a function, right? Like the .then must need to know what to do. So if I'm going to write a function and I'm going to pass that function as an argument, to dot then, what is this function known as? What would you call this function? Callback, right? Starting to make sense a little bit? Cool. So I have a function here that I can do literally inline. I can write the function inline here, or I can write it outside and put it in like we talked about on day one. Do you remember that? But for right now, just for the purposes of like explaining, I'm going to write it inline so you can see exactly what's happening. So this promise is going to go get this network request, and then when the network request is done, I want to do something. So in this function, in the same way that the dot each, the dot map, any of the iterators must receive an element to iterate over, this callback function is saying like, yo, you're going to go get some data, and then you're going to do something. Well, this callback has to get what? What should it receive? It should receive the data, right? It should receive more explicitly in the Ruby what came back here from REST client. What came back here from REST client? The response, right? I made a request and I got a response. So in the same way that it fetches a network request, the callback has to receive the response. What came back from the request? So far, so good. So I'm going to put a response. All I'm going to do is now, who knows what the response is? Well, what should we do if we're like a little bit unsure? We need to test, right? So how can I test? I'm going to drop a debugger right here and test what is the response. So let me actually like forward this on a little bit. If I refresh, I could see that I'm now in, oops, did I not save? Embarrassing.
It's there.
Oh yeah, sorry, the function is over there. It's correct. All right. So I'm in the debugger. It just pre-printed for me. What I mean by that is, if you take a look, it chained the dot then like all the way at the end there. And so if I like scroll over, I can kind of see like the function with the response. So let's take a look at the console and see what is response, right? That would be the most important thing to try to like, dig into. So I'll take a look at response and I go, oh, okay. What does that look like to you? The curly boys. Followed by this. How would you describe what just came back? Oh my God, there's nothing for me to teach. Yes, a response object, right? I'm so actually proud and happy. So a response object came back, but where's the data in it? Well, let's take a look in the body. Okay. Something like, there's a bunch of weird things in here. I don't actually know what's in it. But what did we have to do in Ruby to get the data from the response? Right, so it came back at this response object. It said status 200, okay, true, which is great. So that must mean that I must take the response. All right, I can take a look at the response again. And I have to parse the JSON. In JavaScript, obviously it's a little bit more built in. I don't have to like require, there's no gem or anything. I can just do a method called what? .json Derulo, which is a function. If I invoke it, that's weird. I get this promise pending. Interesting. That's weird. Let's take the debugger out and let's try console logging so I'm not actually pausing the code and seeing what's going on. So I'm going to do JSON. And then I'm going to put const, right, parsed JSON. And then instead of the debugger, which pauses the code, there's something else I can do. And I can log it. So I'm going to console log. I'm going to use all my tools here in the Batarang tool belt. Parse JSON. And I'm going to see just what comes back. What actually is this? I think it's a promise. So let's find out. If I refresh, I see promise pending again. That's frustrating. And it's on line 32. Okay, it's on line 32. This must also be a promise object. So far, so good. This parse JSON is also another promise. All right, we getting that? The idea is, what did we do to the first promise? This fetch, returns a promise. And what did we do to that? Right, we invoked the .then on it. So what I'm going to do is I'm going to clean this up a little bit so it's easier to read. JavaScript's beautiful in the way that it's like sort of space and indentation agnostic. So I'm going to do this. I'm chaining .then onto the promise object, and I'm just going to do this a little bit. Because remember, .then ends here. And that must mean if it's a promise, I should then, if this is a promise, I should be able to .then again. After I've parsed the JSON, it gives me back another promise. So here's the thing. What does this function return? What does the function on line 31, 32, 33 return? Well, right now, what does it return in terms of what I've written? What? It technically parsed response is the promise, but what does this function return?
Whatever is returned after assignment, which I think is undefined.
What is it returning right now? Nothing. I haven't written the word return. So if I simply return the parsed JSON, now this function will return the parsed JSON. Right? That just makes sense. So if this is a promise, I'm returning a promise. Yes? If I'm returning a promise, I can then do something to that second promise. And this then receives what? It will receive the return value of the promise it's on. So for example, this fetch returned a promise, right? And the return value of this promise was the response. So naturally, this function receives the response. If this function receives the response and it returns parsed JSON, this function must receive the return value of this, which is going to be what? The parsed JSON. So it's going to get like what came, it's going to get the return from the king, the previous promise. Every single then gets the return value of the previous promise. So far, so good. That's important to know. So what can we do now? What does the scientific method tell us in terms of the process in which we iteratively figure out what's going on? Well, I should drop a debugger and figure it out. So if I refresh, I'm now in this then function, this debugger. I can then figure out what is the return value of the previous promise. It is now the array I'm looking for. So I'm going very slowly. What are your questions about this .then, the callback, the return, this .then, the callback, the argument it receives, how I'm using the debugger, and why it's now an array?
So, is there no body in the last function?
There's no
Like,
body?
where you put the debugger, would you just leave it like that?
I can leave it like that because this function does nothing except the debugger. Because all I'm trying to do is test, hey, what is this?
But isn't that what
It is what I wanted, but I want to test what it is because I'm not 100% sure what it is at this point. As I'm learning new features, as I'm learning new syntax, I want to pause the code, run through it one by one, and figure out what everything is to make sure my understanding is good. Yeah? What's up? Well, remember this returns parsed JSON. This right here is a variable I'm naming. This is an argument. So it could be anything I want. If I put parsed JSON, it will still work. But it's confusing because people will think this and this are technically the same thing. technically, the return value is going to get passed in. That is correct. So if I name it the same, it will work. But the idea that I'm going to use these different variables is because I want to show you that this is a function that receives an argument. This argument happens just to be the return value.
So because it's changed to it, it's a different thing.
Correct. Correct.
Is that true? Because parse JSON is a promise, the return from the previous promise is an array. They can't be the same.
And I will prove that right now.
So for fetch, you're doing a GET request to that URL, right?
Yes, and I'm going to get to how we do more than just get. But yeah.
And then what you're getting returned is like a response, which is really like a JSON.
Correct.
Okay.
Yeah, so I'm going to walk it through one more time. I'm going to get to each one of yours. If I still haven't answered it, just raise your hand again. All right? So fetch returns what? Promise object. All right? And inside that promise object is actually going to be a response. That's what the return value of what this promise is, of what the fetch's promise is. Fetch returns a promise, right? But the promise itself returns a response.
Fetch gets promise, promise gets response. Sorry, I messed up.
Okay, fetch returns a promise, right? And then the promise will give you back what? Remember when I borrowed $50 from Chet and then I was going to do something? Well, my response to Chet is $55 because he's charged me 10% interest. It's like a bank. I will continue borrowing money from you because you're my friend. So this promise has a return value, has a response value inside. I can chain a dot then on a promise. So a dot then is called on a promise. And in the callback, it receives the value of what that promise should be. So here it's going to be a response because fetch comes back. Fetch returns a response, but the promise itself is saying, I'm going to give you whatever the network request should be. So there's some sort of network response. I'm going to take that response, I'm going to parse the JSON, and then I'm going to return it. But remember, this whole thing is actually a promise object as well, which is weird. So like the joke is that like a promise goes on forever, right? You're the only person in the history that I've been teaching this for a year that has laughed at that. Thank you. One of 700. Nailed it. So this returns a promise as well. So if that returns a promise, I can use dot then again, because dot then is a method on a promise. However, this one is going to receive the return value of what the promise is. So for example, if I returned, right, something like silly string or string of lies, this is going to be the return value of this previous promise. So let's prove that. If I save it, finish the debugger, and I return, see this? Let's actually take a look at what the return value from the previous promise is. It's a string of lies. So whatever I decide to return here will be passed into the next dot then callback. So what I actually want to pass in is really the parsed JSON, because that's what I'm trying to get at. In the same way that I did it in Ruby, I got the response object, then I had to parse it to get the actual quote I wanted. So in JavaScript, right, I parse the response to get what I actually want to get. This, however, is a promise. So I do dot then again to get into the promise to get the data that I want. So this function is getting the return value from the previous promise, which should be the parsed JSON. And as we saw, if I refresh again, now it's returning the parsed JSON. If I go and see what is the return value from the previous promise, it is the data from the request that I wanted.
would like to try and like understand the distinction between the promise that is returned from then and then the return value from the function within the dot then. So one is a promise and one is an array, right?
This is technically this right here is technically going to be a promise.
The whole thing.
The whole thing. But what should that promise return? If I wanted to, right, I can return anything. And guess what this whole thing gives me back? A promise, which means I can then do something else. This function is going to receive the return value. So it's going to be probably some string. But here's the thing. Before we even get into this, what is the return? What is this? What is the return value from the previous promise? What is it? It's the parsed JSON, right? Which we've looked at is actually the array. If I have the data I need and it's parsed and it's in the format that I want, do I need to continue running .thens? No, I don't really need to continue running .thens. I finally got the data I want. So that means that in here, I have the data. I have the data I want here, which is just an array. If I have an array, well, I have the data. Now, I can do anything I want with it, like slap it on the DOM if I wanted to. So how can I slap it on the DOM? Like this is now like part 2 to this. So I'm gonna move through this part quickly because this is like from like literally Chet's amazing review lecture and Andrew's lecture from Tuesday. Yeah, I would exactly do that, right? I'd like document.create element and I would make like, I don't know, like a div or like a p tag. Cool. So const p tag, right? Or like some quote from Ron. So now I have this p tag. But what is the text of this p tag? All right, I want to change that inner text of it to what? Right, the return from the previous promise. But unfortunately, this is an array. So how do I get the string out of it? Yeah, I just ask for the index. So now I have the quote, right? I have the p tag. It's got text, but is it on the page? No, so how do I slap it on the DOM? Well, the idea is that I need to figure out where I want to put it, right? Where would I want to put this quote? Possibly in the div where the ID is quotes, right? Do I have access to that div with the ID of quotes? Not yet, but I can, and how can I do that? Yeah, like yo document, what up dog? Let me query select that real quick. And what am I query selecting? An ID or a class or a tag? Okay, an ID, and that ID is what? Quotes? Quotes, thank you. Do I have access to it right now? Do I have access to this quotes sort of on the next line? I should set it to a variable, right? Const, right, quote. What is this thing? It's like holding all my quotes, right? Quote holder would have worked, you know? So now on the quotes container, I want to slap it on the DOM. I want to like add this to the quotes container. How can I do that? Wow, you guys are really good. Chet++, right? And what do I want to add? The parsed JSON? Some quote, okay. So if I get rid of the debugger, which I did, the idea is that on refresh, I make a fetch, right? Do I still need this const data? No, right? It's not really doing me any favors. I make a fetch. This returns a promise. So far, so good. I parse the response, and then once I have the data, I can do something to it. I can slap it on the DOM. So let me save it. Let me refresh. Oh, there it is. And if I refresh, it's going to make a new network request, and it's going to slap it on the DOM. This API returns a random Ron Swanson quote. So every time I refresh, it's just going to give me a brand new one. Stretching or?
No. So why did you set the like a const over there when you could have just done it in one line for a quote container?
Oh yeah. I could have done dot append child here. Yeah.
Yeah. So it wouldn't make a difference if you just did it that way.
It would not. No.
Okay.
So yeah, it wouldn't. No.
Okay.
I don't know. Let me not dive into the optimizations here yet. What I
just curious.
Okay. I will dive into the optimizations, but before I move forward, there were 3 questions earlier. Did I answer all 3? If that's a new question,
Yes.
okay. So I saw your hand, and then your hand.
So the reason why we did 2 dot then was just based on like the structure of that specific API. But like if it was a different API, we might have to like go through it more.
Kind of. The idea is that whenever I make a fetch, it returns a response. I need to parse the response so that I can then use it somehow.
Okay, so you would only need to parse it.
Yes, I don't always have to parse JSON because sometimes if I make a network request, I get an image. Sometimes if I make a network request, I can get a CSV file. I can get all sorts of different types of things. A majority of things that you're going to get on the internet are going to be JSON. So this right here, I don't want you to hard code and memorize, but the idea is that I'm getting JSON, so I'm going to parse it. Almost everything you're going to do in here in the schoolhouse will be with JSON. But just know that, take a look at the response, like we did, see what it is, and then if you understand what the response is, then you can do something to it. If you get a regular plain text string, then you don't have to parse the JSON. Here we're getting JSON back, so I have to parse it, in which case I then, after I parse it, can now do something with it. I think the hardest part about this is the fact that you cannot parse the JSON and then immediately do something. You have to return a promise that holds the return value. That's kind of like the weird gotcha and the trick. Okay. You got a question?
I'm confused as to why you need 2 dot thens. Like, why couldn't all that be in the first one?
Okay, literally like exactly as I just said, is the first one, right? You get the response object. So remember in Ruby you got the response object? I'm sorry, in Ruby you get the response object. Then you parse it and you store it into a variable. The problem with this is it doesn't work that way in JavaScript. Once I get the response object and I parse it, it is now a promise. This whole thing is going to be a promise that should return something. What I want it to return is the parsed JSON. So then I can do something with it. This is the format for the way that fetch specifically works.
So JavaScript just knows if you're calling a dot then on a promise to return like more parse.
It doesn't know that at all. I'm telling it to do that. Every single thing, fetch will return a promise, and then when you do dot then, this is a promise. And if that's a promise, then I can run dot then on it. So a promise will go on forever. In theory, even after I slapped it on the DOM and I've got everything I ever wanted to do, I can run dot then again for fun. Why I would do that, I have no idea. So if I see like 3 or 4 dot thens in your code, I would be like, why did you do that? Just out of curiosity. And then I would listen to your justification. And then I'd be like, cool, or hey, there's a better way, or something like that, right? Are you good with that? Okay.
My question got answered.
Okay.
What if you wanted what if you just wanted the value in the array out of the whole promise chain? You didn't want to do anything with it, you wanted it back
Yes. So the question is, how do I actually get the value out of this array? I'm sorry, how do I actually get the value from the request and then use it? The idea is if I do something like const the data is equal to the return value, should I have access to the data here? Who says yes? Who says no? Why no? Scope, add a scope, yes. Not exactly. The idea is that if I declare it but don't assign it, I can then assign it here. The problem is this is not going to be anything, and I'll explain why. This becomes very complicated. So before I get to that, I want to do an experiment. And I want to have you understand what's going on. So before I get to anything else, who feels good about the two dot thens? All right. What does fetch return? Great. And then how do you actually get to the data that you want? Can you do it? Okay, cool. So let's do this. Ready? This becomes the hardest part of the lecture. Do you guys want to take a short break or no? If we take a short break, we have to move very... All right, here's your options. I will either continue this lecture after lunch or I will finish it now for the next 15 minutes.
Finish it.
Okay. Because, I mean, your guys' 5 minutes is like 20, so then we would just go into lunch.
Oh, yeah.
Yeah. Before fetch, right? And then here, right, I'm a console log, right? Inside fetch, right? Line 45. And then I'm going to right here, console log 100% definitely for sure after the fetch. What order should I see the console logs? Great. I'm assuming hypothesis, I'm going to see the before fetch. Then for whatever reason, it's going to jump this whole thing, read 50, and then come back to 45. So it goes 31, 50, 45, hut, hike, and then we're out, right? So, oh my God, okay, don't like football over here. I'm like, God, I thought this was America. No, so what is happening here? Let me explain very, very carefully and very, very slowly. I'm gonna do my best. You're gonna see more of this. You guys ready to bring back the artist? Here we go. This is the call stack, right? Okay, it's a little wild. The idea behind the call stack is it's called a stack because of very smart reasons, but I call it the stack because it's very much like a pancake stack, where if I had a bunch of pancakes, right, like this is a flapjack and that's a silver dollar, right, and that's just another one. This one's kind of burnt, right? There's 4 pancakes on this stack. So, can you eat this one right here, without removing these 3, unless you're an absolute savage, right? Is there any way you can eat the bottom one?
Yeah. I mean, not if you're talking about JavaScript, but yeah.
I'm not a savage, so I can't.
Yeah, I mean, like, you must be a barbarian. The idea is that I have to remove the first 3 before I can get to the bottom one, right? And so this is a small piece of computer science that I kind of want to talk about. So like Andrew should have went over the very tiny basics of a tree, and the DOM is a tree, right? Does that sound familiar? Great. This is known as a stack, right? It's another type of data structure where there's 3 methods to it, but let's not worry about that. The 2 that I want you to worry about is that there is what is known as a push and what is known as a pop. So I can push something on, and then I can push something on, then I can push something on, and I have the ability to pop it off. But I can only pop off the top one. So if I push 2 and then I run pop, which one comes off? The top or bottom one? Top one, right? So JavaScript runs all of your code in a stack data structure. What I mean by that is I can have 2, 3, 4 lines of code, and all of them are, ooh, you like that F? Ooh. I'm on the touchpad. I'm surprised none of you are more surprised or impressed. Okay, all right, I want to see you do this. I mean, this is hard. The idea here is this. If I'm running JavaScript, right, I want you to keep this in mind, right? 1, 2, 3, 4. What I can do is I can have function fun1, boop, boop, and then I can have boop, 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 boop. All right, I can do 2, 3, 4 functions. And so function, thank you, is the count from Sesame Street for those. Does anything make you laugh? My God. All right, function 1 will invoke function 2, right? And function 2 just happens to invoke function 3, right? And then function 3, what does function 3 do? What guess? That's right, it returns, right? Cool. Gotcha. No, but I'm sorry. I know you're really excited about that. But I do need to stop function 3. And then function 4 simply returns, okay, because I'm boring. So the idea is that function 1 calls 2, 2 calls 3, and then 3 returns. And then function 4 will run. So if I do something like this, fun1, and then I do fun4, I'm invoking fun1, then I'm invoking function 4. So far, so good, right? So here's what happens in JavaScript, in the call stack, how your code actually gets executed. Well, function 1 will run, so it will pop on the call stack. So bloop, this is now function 1, the pancake. Now what does function 1 do? It invokes function 2. So does function 1 pop off the call stack? Is function 1 done executing? No, it calls function 2. It's like, yo, what up, dog? Let's hang out. Unfortunately, function 2 is very small, and it's like looks like this. Right? They're all the same size. Right? Now, function 2 does what? It calls function 3. So is function 2 done? No. So function 3 comes on, and function 3 has been getting gains. You know what I'm saying? Very good. Thank you. Now, what does function 3 do? It returns. Return means the function is done. So if the function is done, it pops off the call stack. Now, is there anything else left in function 2 to do? No. So function 2 is also done, which means it pops off the call stack. Is there anything left for function 1? No. So function 1 must pop off the call stack. So that would mean that function 1, right, is running. You will not see function 4 run until 1, 2, and 3 are done based on this code. So function 1, in a way, is blocking function 4 from running, right? Because it has to run 2, then 3. So far, so good. So the idea is that function 4 has to sit around and wait its turn. What if function 1 calls function 2, and function 3 doesn't return a string, but is a network request? That means that function 4 can never really run if this network request was slow and was blocking. That's a terrible user experience that we talked about earlier with that while loop, right? I don't want all this code to run, make this network request, because then the rest of my code doesn't run. 4 never really runs if function 3 makes a blocking, slow network request. So the idea is this. Let me finish this thought. Yeah. The idea is this. What if the network request, right, wasn't blocking? It didn't matter how long it took. It wasn't blocking, but it sort of popped off the call stack, and that way function 4 can run. And then it pops off the call stack and goes somewhere else to handle. So the idea is that 1 will come on, 2 will come on, 3 will come on. It's making the network request. But if the network request finishes immediately, 1, 2, and 3 pop off, and then 4 can run. So this is what happens. It runs a network request, right? But what does fetch return? A promise. It returns a promise so that when it goes on the call stack, it returns a promise immediately and pops off. It is not blocking. Does that make sense? It just goes, oh, return, and it leaves so that the rest of the functions can run. But where does it go, right? If function 3 does the network request, immediately returns a promise, pops off the call stack, where does it go? That's why I want you to watch that video, right? And I'm going to break that video down. The idea is that Chrome, let's try this. Ooh, yeah, you like that? Y'all like that? Y'all like that? Okay, it was pretty good at first, and then I failed. But the idea is that Chrome, the browser, can now handle it. And the analogy I like to use is, you ever have like a pop-up come up? Like, for example, like earlier, just now, actually, if I do this, you should see there we go, this right here. This right here is like a pop-up, right? This page loaded and this network request loaded at the same time. I just happened to see it visually, right? Because it popped up on my screen. The idea is that, what if, when it pops off the call stack, Chrome makes that request for you? So what it'll do is it'll go into Chrome, it'll enter a different type of data structure. I don't really want to get into it. It's like a heap, but whatever. And the request goes in here, right? There's like some sort of network request. You know that spinning thing? It's like, it's like doing its thing. When it finishes, it will then pop into what is known as the event queue. So it goes in here, and then it goes all the way to the front of the line. And it's number 1. This is what's happening. Your code is running, right? 1, 2, 3, 4. Let's say you have 600, 700 lines of code, and it's running. And in the middle, right, line 500, your network request finishes, and it goes into the event queue. Well, now it has to sit here and wait, and it doesn't know when to pop onto the call stack because things are coming on and off really fast, right? Console log runs, another function runs, another function runs, another console log, and another console log because you're a dirtbag, you're really trying to debug something, and another function runs. And then your call stack finishes on line 700. Like, all your JavaScript is done. Well, the event queue is very polite. It's like a very nice English man, and it doesn't play cutsies, it doesn't line jump, it doesn't jump in until all of your JavaScript is done. All 700 lines of your code are done. Which case, it goes, oh, you're done, you're clear, there's nothing on the call stack, and then it pops right back in. And then it executes the code. So, to take that whole analogy, right, this is what's happening. I run the console log. That goes on the call stack, it finishes running, and it pops off. This fetch goes on the call stack, immediately returns a promise, and goes into this nebulous event loop. Chrome is now going to handle it. Because it returned, this whole thing gets stored into the event queue. The callback gets saved. What to do gets saved into the browser. This whole thing, 55 to 69, gone. Then it runs the console log. Sometime during all of this code here, mine like 9,000. It's over 9,000, right? 72 ran. So console log 1, fetch, console log on line 72. Now, the fetch goes here, and then when it finishes, it waits until the call stack is done. Then it pops back in, which makes sense because guess what order we see the code execute? We see before the fetch goes on the call stack, pops off, the whole thing, 55 to 69, is stored and saved somewhere else. Line 72 pops on the call stack and leaves. So I see before the fetch, this whole thing is being handled somewhere else. I see this line of code run. It gets all the way to the bottom. It goes, oh, the call stack is clear. This comes back now, and then runs. So then you see line 67. After the call stack is clear and all my code ran. So that all being said, I'm gonna get to your question. That all being said, I need to see like a really strong show of hands here. Does this make sense to you? Why this would happen? Okay, what's your question?
I have a few questions. So, is it like 1, 2, 3, 4, 4 is at the bottom of the pancake stack?
No, 4 is on the top. 4 should be on the top.
Okay.
So the idea is like if it's 1, then 2, then 3. If 4 gets called as well, it's on top.
Okay.
But that's only if they're calling each other.
And then is the pop-up that you talked about, is that the promise or is that the last?
This is the pop-up I'm talking about. Chrome will run the network request. It'll actually go underground and it'll do the network request. It'll go to like Ron Swanson quotes, whatever. It'll come back with the JSON and wait right here with the JSON. And when the call stack is done, it comes back with the JSON, and guess what it needs to do with it? Well, then with the response, you parse it, and then you return the response. This is a promise, which actually, ironically, goes around, but there's nothing else running. So it just comes right back. And then this one runs and slaps it on the DOM and also console logs at that time. So that means that this ran, and this ran, and then these will run. Is that okay?
So the console.log before fetch, is that like when 1, 2, 3 execute? And then
You can think of it that way.
like it sends the fetch request or the get request to the fetch.
Yeah. This goes on the call stack and then pops off immediately because fetch returns a promise immediately so that it's not blocking.
But is that promise the pop-up or is that the Chrome thing?
The promise goes into Chrome to handle the request. The analogy of the pop-up is simply that Chrome can run multiple requests at the same time. That's all that means.
I'm just saying like if it sends some sort of immediate promise, that's not something that the user can see.
Correct. Like this right here, right? I'll put it this way. Imagine I disconnected the screen so you can't see it, right? And I'm on Chrome and I go to like coolcats.com. I don't know if this is a real website or not. I'm not going to actually go in case it's something wild. But if I didn't have the screen connected, I'm still making the network request. But once it finishes loading, I can essentially plug the screen back in and then you'd see it. So that whole thing that's happening in the background, I can kind of hide from you. And so when fetch goes and runs, when it goes into the event queue, it's being hidden. But when does the data come back? Well, it kind of has to wait until all your JavaScript is done before it comes back because it doesn't really know when to actually execute. It has to wait until the end. It doesn't like line jump. It doesn't cut the call stack line. Okay, so that all being said, the last thing I want to leave you with is remember a queue is when 1 goes on, then 2 goes on, then 3 goes on. What has to come off before 1 or 2
After a queue.
for this stack? Well, if 1 goes on, and then 2 goes on, and then 3 goes on, what has to happen if 1, 2, 3? How do I get to 1? 3, 2, 1. So the idea behind the data structure of a stack is the first in, if number 1 goes in first, what order does number 1 have to come out? Last out. So a stack is first in, last out. So far, so good. Now, a queue is exactly like what it sounds like. A queue, which unfortunately is the letter Q followed by 4 silent letters. It's kind of stupid. Is a line, right? You're at the supermarket, right? You're at the supermarket, and this is the register, and this is the line. You go in first. Somebody goes behind you, then someone goes behind them, and then someone goes behind them. Who goes to the cash register first? And then who goes? Number 2. Then who goes? Number 3. So when it comes to a queue, the data structure of a queue, it's going to be first in, first out. So there's I snuck in a little bit of computer science there as well, all right? So now you should understand how stacks and queues work generally, just a vague generality, all right? You should understand at this point asynchronous requests, what the event loop is sort of doing, and that is handling your network requests like hidden from you. And then it chooses to come back only when all of your JavaScript is done executing. You should understand why the order of this happens. You should be able to make a request, get the data, and then do something with that data. You should also understand that because I've declared this here, I do not have access to it here because of scope. And that's essentially fetch and async. The last thing I will say is you'll hear the term ajax a lot, AJAX, and it stands for asynchronous JavaScript and what is known as XML. XML is still used today, significantly less, but it's a markup language, right? In the same way that HTML is, XML, ML just stands for markup language, and that's just a way of like holding data. It is dated and it's old, and we could talk about it offline, or I'll bring it up in our next lecture. It's still being utilized today, but instead of XML, most people use JSON. So it's almost like you can think of like AJAX, asynchronous JavaScript, and JSON, right? But they still call it AJAX, just so you understand what that is. All right, are there any like wild pressing questions, something you maybe don't understand? Hopefully I did a decent job explaining that, but.
So you said in the beginning that JavaScript is supposed to be synchronous.
Correct.
So then,
By using fetch, which is asynchronous, you're actually offloading so that the call stack can continue running. Very good. Thomas, and then
So basically, all fetches in JavaScript are going to be sent to the queue.
are going to send to the event loop, yes. And then they will put it into the queue. Chrome will do that.
So the stack technically generates a promise, and that's the promise is what's sent to Chrome, or does
The stack doesn't generate a promise. Fetch will return a promise. And that's why it pops off the call stack.
so
And it
promise
goes-
is sent to the call stack? Not.
A promise is sent to the event queue to finish the network request. And then when it comes back with the data, it runs the callback function.
Okay, so the promise is generated in the event queue by who? Who generates the promise? Like what point in the cycle?
Fetch, which is a,
So you have your function in the call stack.
right. Once fetch goes on the call stack, it returns a promise and pops off. It now will enter the event queue because fetch is actually a browser API. Like,
So the promise goes to the event queue and waits for the response from Chrome, and then it pairs the two and sends it?
you could think of it that way, yeah.
Okay.
Remember, window is like the global object, right? Fetch, you would think is like, oh, that's kind of cool. It's actually window.fetch. So Chrome actually gives you the fetch command. Fetch is not organic to JavaScript.
Oh.
So like, if you know anything like about Node and stuff, Node has no fetch. So that's why it knows how to go to use Chrome, because Chrome is actually giving you this API, this function. So when I run fetch like this, technically speaking, I'm doing this, but I can just leave that out. So that was just the GET request. Tomorrow, we're going to talk about how to use fetch to do way more than GET. Like, how do I do the post, patch, put, delete, and like actually start manipulating my database so that when I do something with the DOM, it's not just like on refresh it goes away, I can start persisting that data. Cool? All right, that's all I have for you. If you have questions, we'll talk offline.
Cool.
Thank you.